This question is somewhat inappropriately labeled calculating molarity using solute moles. A chemist prepares a solution of copper 2 fluoride by measuring out 0.00887 micromoles of copper 2 fluoride into a 50 milliliter volumetric flask and filling the flask to the mark with water. And then it says calculate the concentration in millimoles per liter for this solution. So when it says calculating molarity, what it actually wants us to calculate is millimolarity, because this is millimoles per liter. And that's not really a big deal, but we do need to just be conscious of the fact that we're not trying to actually calculate molarity. So molarity is moles of solute per liter of solution. So millimolarity equals millimoles solute per liter solution, which is exactly what they ask us to find, millimoles per liter. However, of course, we're not given what we need. We're given micromoles instead of millimoles. So we need to convert this micromoles to millimoles, and we need to convert these milliliters to liters, and then we can do the division. So to do this, what we should do is, starting with 0.00887 micromoles times, there are 1,000 micromoles in 1 millimole. A micromole is a millionth of a mole, and a millimole is a thousandth of a mole. So there are 1,000 micromoles in a millimole. So we want to get micromoles to cancel out, so we put 1,000 micromoles on the bottom, 1 millimole on the top, and multiply by the top, divide by the bottom. We get a very, very small number, so I'm going to write it in scientific notation, and that number is 8.87 times 10 to the minus 6 millimoles. We now want to convert our milliliters into liters. And if you could do this in your head, just go ahead and do it in your head. But if not, we have 50 milliliters times, there are 1,000 milliliters in a liter, so we put the 1,000 milliliters in the bottom, 1 liter on the top, multiply by the top, divide by the bottom, and we get 0.050 liters. Now we have our millimoles, we have our liters, so we plug in 8.87 times 10 to the minus 6 millimole divided by 0.050 liters. And when you do that math, the calculator tells you 1.774 times 10 to the minus 4 millimolar. However, since the volume here is two significant figures and the amount of solute, the moles of solute, or in this case millimoles of solute, is three significant figures, and we're doing division, we need two significant figures, so that's the one we need to look at. Since the following digits is 7, we do want to round up. So the best answer is 1.8 times 10 to the minus 4 millimolar. So that's a 4. This is the best answer to this question.